Hi everyone, this is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the classification of materials. So, the materials are probably more deep seated in our culture that most of us realize. That means, anywhere the materials are very important. So, we are using in a daily needs. So, what are the things we are using daily? These are all depending upon the type of materials what we are using. So, if you consider the examples like transportation, in transportation we have a lot of transport like automobiles, railways, buses, aeroplanes. So, all these have a material. The housing, the construction of the housing, this also includes the material. Clothing. So, what are the clothes we are using? So these also having some material. Communication. So what are the communication we are using to communicate the information from one to another? So this also has a material. Recreation, food production. So every segment, every day in our life we are related with material science only. So what are the things we are using every day? So it is related to the materials. So if you see the historical development, the advancement of the society, advancement of the technology, and advancement in the research has been improving the materials based upon the application. So earlier we used to have very limited type of materials. Now because of the research what is happening and the technology development in the society, this needs an improvement in the materials. So that's why there is a lot of research is going on to bring out the new type of materials depending upon the application. So any type of material can be selected based upon the application. So once if you know the application, so and so is the application. Though depending upon the application, you are trying to select the material. So the selection of material is very important, and this selection of material is based upon the application only. So in fact, every civilization have been designated by the level of their materials development. So in the earlier we have the Stone Age. We used to use only the stones as a cutting tools, and later the development we have the Bronze Age, and further it is a Iron Age. So like this, there is a development in the research and the materials. So based upon the development of the technology, there is a vast change in the development of the materials. Now earlier we used to use only the limited material which are available naturally, like stone, wood, clay, and so on. So these are the materials which are available naturally in the earlier days. So these are very limited. So with this limited materials only, they used to perform the cutting operations and etc. So later on, what is happening because of the development in the technology, slowly there is a development in the materials also. So further, there are new type of materials coming. So depending upon your applications, so these include pottery and various metals. So what is happening? There is a lot of research is going on since we have a lot of technology development. So based upon the technology, we have to improve the materials also. So how we are trying to improve the materials? So once if you know the properties of the material, then it is very easy for us to select the exact material for the required application. So suppose if the properties are not suitable for suppose some given application, so what you have to do, we have to improve the properties of the applications. How we are improving the properties? So by doing the heat treatment process. So once you do the heat treatment process, we can easily enhance the mechanical properties of the materials. So what we are trying to do here, we have some raw material. So this raw material we have to heat to the recrystallization temperature. Then we have to add some addition to the existing material so that the properties can be enhanced for the base material. So in this way we have to do. So in this way we'll perform the enhancement of the mechanical properties in the materials by the heat treatment process. Now what is happening here at this point, material utilization was totally a selection process that involved deciding for a given rather limited set of material. So what is happening? The selection of material is very, very important. How you are selecting the material? So based upon the characteristics of the material, you're trying to select the material. And once if you know the physical, chemical and mechanical properties of the material, then it is very easy for us to decide what type of material is suitable to the required application. That's why it is very, very important for us to know the properties like physical, mechanical, chemical properties of every material. Then only we can decide the exact material for the required application. That's why there is a lot of selection. There is a lot of availability of materials. So how you are selecting the materials means based upon your properties. And there are four main components in the material science engineering. So what are these? Processing, structure, properties and performance. So these are correlated to each other. The processing of the material, that is nothing but the synthesis of the materials. Structure, so what is the type of structure you have? And the properties, so these properties includes the mechanical, physical and chemical properties, and also the performance. The last thing is the performance. So all these are interrelated to each other. So once if you change anything in these four categories, so what will happen? The complete the organization or the characteristics of the material will change. Suppose now in the four components, if any property has been the property, suppose the property of the X material has been altered slowly. So what is happening? If this property has been altered, the performance will alter, the structure will alter, also the process of the material will also alter. So once if you alter any small portion of these four components, the complete characteristics of the material will differ. So once one has to identify that if any one value in these four components are been changing, the complete characteristics of the material will go wrong. So that's why you have to check clearly which you have to change, and by changing this, so what is the performance of the material will be altering, as well as the structure of the material will also be altering. So all these things you have to take into consideration. Now when utilizing a material, one needs to understand the structure, properties, processing and performance. So this is very, very important. The selection of a material, when you're selecting a material, we have to understand the concept of the structure of that material, the properties of that material, how it is being processing the synthesis of the material and the performance. And these four characteristics are very, very important when you select a material. So what happens here? When you're utilizing a material, we have to understand all these four components of the material, and since these are interrelated to each other, if you see the diagram here, all the performance, processing, the structure and the properties are interrelated. Everything is interrelated to each other. So once if you alter any processing methodology, okay, once if you alter any processing methodology, what happens? The performance will alter, the properties will alter, the structure will also get altered. And similarly, if you change the structure of the component, what is happening here? The processing will change, the properties will go, the performance will change. So like this, again, if the properties are varying here, what is happening? Again, the structure will go change, processing will change and the performance change. Again, if the performance is being altered, so again the processing will change, structure will change and properties will change. So like this, every component in the material, the four main core components in this material are interrelated to each other. So that's why we have to understand the concept of all these four components. Then only we can decide the correct material for the corresponding application. So this is how the correlation between these four components has been shown in the tetrahedron diagram. And if, as we discussed, if one alters the processing, there is a direct connection within the structure properties. That's why, since we have the direct contact between these four components in the material, so any one component is altered, all the other, there is an effect on all the other components. So that's why we have to be very, very careful when we are changing any property or performance or the structure of the material. So since these are correlated to or interrelated to each other, there should be very, very careful observation while selection of material or any difference you are doing to the material. So adjusting any one factor will have varying degree impact on the other three factors. So any one variation is there on the any one of the four factors, there is a huge variation on the other. So there is impact on the other components of the material. So characterization is the heart of the tetrahedron, signifying the role in the monitoring of the four components. So all these four, the structure, properties, performance, they're all correlated to each other. And this correlation of these components are given by the characteristics. Characterization of the material is implies all these four components: the structure, properties, performance, and the processing. So any characteristics of the component are the four things which we have here. So these four plays a major role when you decide any characterization of the material. So the characteristics of the material are the four components which is having a major role. So this is how when you decide to select a material, or when you try to alter the characteristics of any material, so this is how these four are major components you have to take into consideration while doing any alteration to the material. And why? What is the importance to study the material science engineering? What is the use of to study these things? Means many and applied scientists, engineers, whether mechanical, civil, electrical. So wherever you find, you'll find these type of design problems which involve material. So it is not constrained to only one mechanical branch. It is a multidisciplinary area where these materials are being involved in all type of branches what we are seeing in today's life. So everywhere there is a challenge for designing of material corresponding to your application. Okay, so we have a lot of improvements, we have a lot of options we have. So depending upon those things, we are trying to select the material. So designing of material is very, very important in any type of aspect. So that's why the material science is very, very important, and why we are studying all these things. And also the examples might include the transmission gears in the mechanical engineering, the superstructures for the building, oil refinery components, and integrated circuit chip. So everywhere the material science is involved, it is emerging. Okay, so that's why wherever the transmission gears you have, there is a major role of materials play. Why? Because heavy temperatures, high working process is there. So all this material has to withstand to those high loads. So there the material plays a very, very important role. And again, the superstructure of the building. So you have a lot of huge structures. If you see outside, you have a lot of structures. So all these structures has to withstand to the different climatic conditions. Since the building is exposed to different climatic conditions, so the selection of material is very, very important. You have to resist from the corrosion. So how we are resisting from the corrosion? Since the building is exposing to different environmental conditions, there also again the selection of material is very, very important. If you select the exact material, the composition of the material is perfect, then any type of climatic conditions the building can withstand. And also oil refinery components, there also you have a lot of scaling formation will be there, and you have to work in a long depths. So all these salt coming into picture. So all the material has to not affected with that different climatic conditions. So there is again importance of your material, the chips, integrated chips what we are using here. So all again you have to have very less weight, you have to reduce the weight. So how we are doing all these things means again the selection of material is very important. So material is very, very important in our day-to-day life. That's why it is a multidisciplinary subject where the involvement where the importance of the material in it is being everywhere in our day-to-day life. So that's why every day the research is going on to bring out new type of materials based upon your applications. So lot of engineers, lot of scientists are trying to bring out the new type of materials. They're trying to design new materials and they're trying to investigate different types of materials based upon the applications, based upon the wherever the need is there. So there we are trying to bring out the new type of materials. That is the importance and why we are trying to study the material science engineering. Now coming to the classifications of materials, the solid materials have been conveniently grouped into three basic categories. So what are the solid materials we have? These solid materials have been classified into three categories. So first one is the metals. First category is metals. Second one is ceramics. The third one is polymers. So these are the three classifications where the solid materials have been classified. So metals, ceramics, and the polymers. Now this scheme is based primarily on the chemical makeup and atomic structure, and most materials fall into distinct group or another. So how we are trying to differentiate whether it is a metal or a ceramic or a polymer? Based upon the atomic structure, based upon the properties of the material, based upon the preparation of the material, based upon the synthesis of the material. So all this comes into try to classify the materials. So once if you want to differentiate the material, we have to know the properties as well as the atomic structure of the material. So in this way we can easily classify the different types of materials. Now in addition, there are composites which are engineered combination of two or more different materials. So apart from the metals, polymers and ceramics, we have some advancement in the materials like a composite material. So composite means one or two materials which are combined, combined and looks like a single material, then that type of material is called as a composite. So it is not a single material, it is a combination of two materials but looks like a single material. So that is called as a composite. So this is some of the advancements in the materials. Another category in advancement materials are those for high technology applications such as semiconductors, biomaterials, smart materials and nano engineering materials. So that's why based on the application, we are trying to bring out the new technology, new type of materials. So why we are trying to bring out the new materials means, so since we have a lot of applications we have, so the earlier materials what we use are not suitable for the current applications. So that's why there is a advancement in the research or advancement in the materials based upon the applications. That's why what are the metals or ceramic or polymers which are using, still these are not coming to complete satisfaction levels because of these applications. We are trying to bring out the new type of materials like a composite materials and another advancement in the materials because of the high technology in the biomaterial and smart materials. We'll see further what is happening in each type of materials. So first if you see the metals, so what is a metal? So materials in this group are composed of one or more metallic elements. So wherever the materials which is composed of one or more metallic type of elements, these type of elements are called as a metals. So example, if you see here, iron, aluminum, copper, titanium, gold and nickel. So these are some of the examples which comes under the metals. And often also non-metallic elements like carbon, nitrogen, oxygen is relatively small amounts. So composition which is composed of two or more. So when the aluminum is composed with carbon, aluminum carbon or aluminum nitrogen, aluminum oxide, so like that it is a composed of two metals. So then the type of things are called as a metallic elements. So if you see here cast iron, this is one of the important type of metals which we are using in the industry. Wrought iron, aluminum, steel which is used in the constructions, copper, which is a good conductor of electricity, zinc, brass, carbon steel, lead, tin, titanium, and elastines. So these are all the examples comes under metals. So what is a metal? Metal in this group is composed of one or more metallic element. Then that type of metals are called as a combination of metals. And again, uh, this is composed of with non-metallic elements, which is having very less percentage, very relative small amounts. So complete metallic element with small amounts of non-metallic elements comes under the group of metallic elements. So that is about the first category. And coming to the second category, we have the ceramics. So what are ceramics? Ceramics are compounds between metallic and non-metallic elements. So wherever you find the materials between the metallic and non-metallic elements, so that group comes under the ceramics. Okay, so ceramics comes under between the metallic and non-metallic elements, and they are most frequently of oxides, nitrides, and carbides. So mostly these are nitrides, oxides, and carbides. So for example, common ceramics, if you see here, it includes aluminum oxide, silicon dioxide, silicon carbide, silicon nitride, and if addition some other ceramics based upon your applications, we can use the porcelain as well as the cement and glass. So these are some of the classifications of different types of ceramics which comes under, which comes between the metallic and non-metallic elements. Majorly they are composed of oxides, nitrides, and carbides. So these are some of the pictures. You can see the ceramic materials or ceramic components which are being prepared. And the third category is the polymers. This include the familiar plastic and rubber materials. So like this, see, the metals will have different properties, the ceramics will have different properties, and polymers will have different properties. So based upon the properties only, these materials have been classified. So if you see the polymers, this is completely different from the other metals and ceramics. So what is happening in the polymers? They include familiar plastic and rubber. So plastic and rubber type of things comes under polymers. So many of them are organic compounds that are chemically based on carbon, hydrogen, and other non-metallic elements. So further, they have been large molecular structure. So these have very large molecular structure, often like a chain-like structure we have, and they look like a backbone of a carbon atom. So this is how the structure of the polymers will look. So some of the common familiar polymers are polyethylene, polyvinyl chloride, polycarbonate, and polystyrene, and silicon rubber. So these are the different types of common familiar polymers which have been used in our day-to-day life. Are the polyethylene, polyvinyl chloride, and polycarbonate, polystyrene, and silicon rubber. So this is how we are classifying the materials based upon the three categories, that is the metals, ceramics, and the polymers. So how we are trying to classify means based upon the characteristics, based upon the atomic structure, based upon the physical characteristics or the mechanical properties and the chemical properties. So this is how we have to one will differentiate the type of materials. And these are the different polymers. You see here, natural polymers, synthetic polymers. So with the help of the synthetic polymers, we can use all these plastic bottles. Okay, inorganic polymers, organic polymers. So as we said, it looks like a backbone type of structure, a chain type of structure. It is having a large molecular size. So these are some of the examples of different polymers. So like this, each material will have its own application. So we can't make the plastic bottle with metal. Similarly, we can't make the plastic bottle with ceramic, like that. So depending upon our application, we have to select the proper material. So how we can select the proper material? If you know the structure, the composition, as well as the properties of the material, then it is very easy for us to select the material. The selection of material completely based upon the properties and the atomic structure of the materials. And coming to the other advancement in the materials, apart from the three modes, that is the metals, polymers, and ceramics, we have the advancement in the metals based upon the new technology. The next category is about the composite material. So, what is a composite? It is a special additional classification of composite materials, which is composing of two or more materials. So, if you add two or more materials and combine to a single material, so what is happening? A single material will have a good properties. Now, if you add two different types of materials, the properties are increasing here. So once, if you want to enhance the properties, or if you want to increase the properties of material, we are trying to add one other material, so that there is an improvement in the properties as well as the mechanical chemical properties. So that is called the composite material. So these are having again metallic, ceramics, polymers. So all these different types of polymers we can combine to a single, as well as the different types of metal also we can combine into a single, and ceramics also we can combine into single, and these are called as composite materials. Now next category is the advanced materials. So what is happening in the advanced? So where high technology, where we are using high technology, then we can use these advanced materials. So these materials are typically enhanced or designed to the high performance materials. So that's why, depending upon the application, if you require very high advancements, high technology is required, there we can use these types of advanced materials. So if you see here, composite material, so you have different types of fiber reinforced here. So all these three are combined to a single finished product. So we are trying to bind these three and look like a single component. So each fiber component will have different properties and compositions. So now if you combine all these together, and if you see the combined properties, you can have an increased enhancement in the properties rather than seeing the individual. So like this, you are using some adhesive and trying to bind these components to look like a single, and this is the finished component. So this is how a composite material is being developed. And here you have advanced material. So in the jet planes, aerospace industry, there is a need of advancement in the materials. Why? Because the airplanes has to fly to a high altitude, and during that high altitude, high wind velocity, it will be hitting on the body of the aeroplane. So this high velocity has to withstand, otherwise there is a failure in the material. So that's why, since the high technology, high advanced materials are used in these types of applications. So that's why, if you use a small component in these advanced material, there is a large failure. So that's why, if you know the application, since the aerospace industry having a good large applications, so based upon that application, you're selecting the advanced materials. We are not using here any type of polymers or ceramics or metals. Instead of these three, we are going with the high advanced materials. Why? Because there is a lot of difference. There is a lot of huge difference in the application. So application oriented, you have to select the material. That is why in these aerojet or airplanes or jet planes, we are not using any type of metals or ceramic or polymers. We are using only high advanced materials, since the application is very different. And semiconductors and other materials. So this can be made to switch from an insulator to conductor. So there we will use the application of voltage. So there also we are using these type of semiconductor materials, where we are making the switch from an insulator to a conductor. Why? Because the flow of electrons in the semiconductor is somewhere between the insulator. Okay, so to flow the electrons freely, so we are trying to bring out the semiconductors in the integrated chips. And because of the development of the semiconductor for integrating of the circuits, this has been a revolution in the computers, what we are seeing from the last 50 years. So there is a huge difference, huge technology difference. If you go further beyond the 50 years, and now there's a lot of change in the technology because of these semiconductors and the integrated circuits. We have a large revolution in the computers which we are experiencing from the last 50 years, and because of these things, what is happening, these materials have enabled our digital electronic age. And the other type of materials is the nano materials, and these nano materials which is having a size typically from 1 to 100 nanometers, and these materials are in size and geometry can play a significant role in the dominant material properties. So these nano materials, again, nano means 10 power minus 9 microns. So the size of the particle is very less. So since the particle size is very less, so the spread of the nanoparticles over the area is very high. That means the properties of the nanoparticles are very high when you compare with the metallic elements. So in this size of range, the quantum mechanical effect can dominate, as well as the chemistry, due to the large number of atoms being surface atoms instead of atoms in a bulk. So if you consider atoms in a bulk, and if you compare the nanoparticles individually, the surface area, the spread area of these particles is very high when you compare with the bulk size. So because of the spread area is very high, the enhancement in the properties will be very high when you compare with the bulk size of the material. So that's why these nanomaterials are very important. In addition to the size, these materials sometimes exhibit unique functionality due to the geometry. So because of the geometry of the nanoparticles, the functionality of the nanoparticles is very high when you compare with the normal things. So example, if you consider the gold nanoparticles, they can be very chemically active, unlike bulk gold. So bulk gold, if you keep aside with the nano gold particles, so this will have a high performance when you compare with the bulk gold. Why? Because the nanoparticle size, the area, the spread area is very high when you compare with the nano bulk gold material. So that is how there is a lot of difference between the nano as well as the bulk component. Next is the biomaterials. So these biomaterials are very useful in the medical applications. So where we can transplant the veins, blood vessels, the stents what we are using. So all this, the performance, the design, the functionality. So the selection of material is very important again in the biomedical applications where we are using these materials. So why? Because whatever the materials we are keeping inside the body, so this will again exposed to the different wet and chemical activeness which we release the immune response, everything. So what is happening? It will damage the material inside. So we have to protect the stunts or whatever the material we are trying to incorporate inside the body. So again, the selection of material is very important there also. So that's why these materials, biomaterials, where we are implanting inside the body, has to have a good material properties. So since the body might attack the biomaterials as a foreign material, foreign body, and the environment, so where we have the wet and climatic chemically active in the body, is typically leads to corrosion. So this you have to avoid. And smart materials, there is also design in the biological behavior. The materials like biological system respond to the stimuli. So where the material system is utilizing the smart materials. So this is how there is a lot of development in the materials. So if you see from the Stone Age and to the Metal Age, Iron Age, there is a lot of improvement in the materials. So there is a lot of different types of materials, and these different materials we have to differentiate with the help of these properties as well as the atomic structures, and based upon the application we are trying to select the material. So every material is not suitable for the everything. So different materials will have different properties. That's why based upon the application only we have to select the material. And if you see the different types of materials density, if you see the bar chart, so the density is on the right side, so gram per centimeter cube. So metals are having very good density when you compare with ceramics, polymers and composites. Okay, so metals will have higher density when you compare with the ceramics, polymers and composites. And if you see the stiffness or the elasticity, metals and ceramics as well as composites are almostly equal to each other. If you see the stiffness comparison, metals, ceramics and composites will have almost same level of stiffness when you compare with the polymers. Polymers will have a lower level of stiffness or the elasticity when you compare with the other three types of metals. And if you see the strength, that is the tensile strength, if you see, again the metals will have a higher rate of tensile and almost similar to the composite. So composite and metals will have similar strength, and ceramics as well as polymers again will have lesser strength. So the properties are varying. We can see here metals are having different types of properties, ceramics are having different types of properties. So that's why based upon the application you have to select. Next, coming to the resistance to fracture. So which are having good values is metals. Metals will have a good resistance to fracture. And coming to the second thing, you have the composites. So first category is the metals, second are the composites, and of course third ceramics, and fourth is polymers. So this is how the resistance to fracture can resist the body. So heavy load type of applications, if you are selecting, then you have to go with the metals. As a second option is your composites. So that is how you have to select the material based upon that application. Next is the electric conductivity. So during the process, if any manufacturing which is related to electrical conductivity, so where the electricity is passing, so what type of materials you have to use? Metals and semiconductors here. So these are having a good electrical conductivity. So that is how you have to select. And ceramics, polymers does not have. And if you see the familiar objects which are made up of metals and metal alloys, the silver fork, scissors, coins, okay, wedding ring, nut and bolt, gear. So these are the different types of familiar which we see in our daily life, which is made up of metals and metal alloys. Okay, these are the some of the pictures you can see, identify, and these are the ceramic materials. So all these things, whatever we are seeing in the slides, these are our daily basis where we watch. So that's why I'm giving these examples. So these are the ceramic materials. You can see the teacup, the brick, the tiles, glass vase. Okay, these are some of the examples which are being commonly used in our day-to-day life, which is made up of ceramics. And coming to the polymers, you see the polymers, again some of the common objects which are made up of polymers are plastic tableware, which we have the spoon, fork and knife, billiard balls. So these are made up of again polymers. Bicycle helmet, this is made up of polymer. And two dice, what are the dice we are using to play, and the lawn mower wheel, and the plastic milk carton. So all these are which are commonly used in our day-to-day life, which is made up of polymers. So these are the classifications of materials, why the materials are very, very important, and what are the different types of how the materials have been classified, and what are the advancement in the materials. So everything we have learned in this session. And if you want to have the reference, you have the Introduction to Physical Metallurgy by Tata McGraw-Hill, Sidney Haviner, and Essential of Material Science Engineering by Donald, and Material Science and Metallurgy by Kodigiri, and Material Science Engineering by William Castler. So these are some of the references where you can find the classifications of materials, and what are the properties of the materials, what are the physical, chemical, mechanical properties, and what is the importance of each material can be taken from these references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.